Alright, hi guys. So we are going to attempt, hopefully I'll do better at it this time than I did the other day. We are going to attempt to go through this lesson that we covered literally last Thursday, which was a week ago now. But since we were out Monday and Tuesday, and then kind of snowballed from there, no pun intended. So then being out Wednesday, being out Thursday, I'm going to cover everything, and this will also include what we already covered plus what we didn't get to. And I know that this lesson kind of racked our brains a little bit, so you're going to want to rewatch the whole thing regardless of if you're just like zooming through this. You're going to want to rewatch it anyhow, just to make sure that you are up to date and that you have the last two filled in, or the last thing, it was last page filled in before we come back to school tomorrow. Okay. All right. So with that being said, let's go ahead and get started. All right. So reading problem number 1. Okay. Given the initial condition y1 equals 2 and the particular solution of the equation 3x squared y prime minus x equals 0. Okay, so we're going to go ahead and we're going to try to isolate our y prime here. Okay, so move the x over first, and then we're just going to divide by everything that's not y prime. So y prime is going to equal x over 3x squared y squared. Okay. And then we know that y prime is just the same thing as dy dx for us. And then remember, whenever we start to cross multiply, we want to have the x's across from the x and the y across from the y. So in this situation, we have an x on the top and the bottom. But I'm going to simplify that right there just to x to the negative 1. So we're going to have x to the negative 1 over 3y squared. All right, so now we can cross multiply. And then from there, you know, we can go ahead and take the antiderivative. All right, so there is our formula, okay? And then they gave us a condition up here. So with that condition, we know that our x is 1 and our y would be 2. So I'm going to plug that in. So 2 cubed equals ln, absolute value of 1, which we know is just ln of 1. Okay, plus c, and ultimately here we're solving for c. ln of 1 is 0. Therefore, 8 is our c. Once we have our c, we can plug that back in and get our actual equation. Okay, which would give me y cubed equals ln absolute value of x plus 8. Or if you wanted to get y all by itself, it would just be y equals the cube root of the ln of the absolute value of x plus 8. Both are acceptable, just a matter of choice on that. All right, moving on to problem number 2. All right, find the equation of the curve that passes through the point 3, 2 and has a slope of negative 4x over y cubed at any point x, y. Okay, so go ahead and jump right in with your dy dx. Okay, so we're good here. Our x's are across from our x's, y's from y's, so we're going to go ahead and cross multiply. So y cubed dy is going to equal negative 4x dx, and we can take the antiderivative there. So 4 is going to be 1/4 y to the fourth. That becomes a 2. Negative 4 divided by 2 is going to be negative 2x squared plus c. And again, they gave us a condition. So we've got an x and a y. Plug those in and see what happens. 1/4. Our y value will be 2 to the fourth. Negative 2, 3 squared plus c. And we're solving for c. So 2 to the fourth is going to be 16. A fourth of 16 is 4. 3 squared is 9. 9 times negative 2 is negative 18 plus c. So ultimately our c is 22. All right, so if we plug that in, okay, and let's try to make this just look a little bit better. I'm going to multiply everything in here by 4. And again, that is a completely acceptable answer, or we could isolate by taking the fourth root. So that's going to give me the fourth root of negative 8x squared plus 88. Now, there's a little note on our notes in Canvas about normally when we take an even root, we have to do the plus or minus. But considering we were given a particular solution up here and our y value was positive, okay, we don't have to put the plus or minus because we know that ultimately our answer here is going to be positive. I'll write that in again. Okay, so we're not just throwing that out. We are mindfully eliminating it based on our data. Okay, all right, and then down here you're going to notice just this is our given relationship, okay, where normally dy dx is our rate of change of y. Okay, our k basically means is proportional to. And this is the given relationship between variables. So we talked about the k being the proportionality constant. All right, so basically we're saying the rate of change of y is proportional to the given relationship between the variables. And we're going to use this general idea over the next several problems. All right, so example number 3 is where we kind of got overwhelmed the other day. There's just a lot going on and a lot to solve for. So just kind of try to clear this up a little bit. All right, that's the best I can do, y'all. Sorry. All right, example number 3, the rate of change in the number of foxes, n of t, in a population is directly proportional to 550 minus n of t, where t is the time in years. When t equals 0, the population is 250, so we know automatically that's going to be important. And when t equals 3, the population has increased to 500, so we know that's going to be important. They want us to find the population when t equals 5. All right, so let's go ahead and start talking about using what we just had. Okay, the dy dx equals k times the given relationship. All right, well, they gave us the given relationship right here. Okay, so we're going to start with that. dy dx equals k times 550 minus n. Also, y'all, FYI, I am working here with no whiteout, which is a huge thing for me, so hopefully I don't mess up too many places. I almost did right there. All right. So dy dx equals k 550 minus n. So already we know we've got a couple of unknowns here. And if you remember, this is where we have to solve for a couple of things to make this work. All right, so, and that should be dn dt. Look, told y'all. That's what I get. Y'all know I can't handle it, so we're going to go ahead and start over. All right, dn dt. All right, there we go. Okay, nice and pretty. All right, so again, we want everything to be opposite of each other, so I'm going to start by moving that 550 minus n down So it's going to become 550 minus n to the negative 1 power. Cross multiply. And then once we get to here, we can take the antiderivative. All right, so this is going to become a 0, so we know we're going to have a natural log there. So ln okay, and then this will just become kt plus c. All right, now understand this. Whenever we did this, most of the time when we've done this, or several times when we've done this, this has been some sort of plus here. Okay, so if you were to take the derivative of the inside here, it would have given you just a positive 1, which was not relative for us, okay, or relevant for us. So, but here, if you take the derivative inside, we would have had a negative 1 somewhere. Okay, so we've got to account for that negative 1. So I'm going to go in here and I'm going to put that minus out front here, because we would have had a negative 1 in that numerator. Okay, so we need to keep that in there. All right, now from here, basically I'm going to go ahead and divide by that negative. So the left side's going to stay ln absolute value of 550 minus n. The right side's going to become negative kt minus c. And now we're going to take the e to get rid of the ln. Okay, so that's going to cancel these. So I'm going to just be left with 550 minus n e to the negative kt minus c. Okay, I did drop the absolute value bars because, y'all, we talked about how your population, your number, is not going to drop below 0. So there's no way that the 550 minus the number that we're dealing with is ever going to become negative. So we would not need to apply the absolute value there. So we went ahead and dropped those. All right, solve for n here, and we're going to get that n is going to equal 550. So basically, I'm going to move this n over here and this e over here, minus e to the negative kt minus c. All right, so I'm still stuck. I don't know k, t, c, n. There's all this that I'm still working with. Okay, so now we're going to go and see. We did get some information, 0 and 250, 3 and 500. And we're going to use that information to try to find our c. Okay, so if we know that t is 0 and the population is 250, so we're going to put 250 on the left for our n. 550 minus e to the negative k times 0 minus c. All right, so that's 0, so that's minus c. Move the 550 over, so negative 300 would equal negative e to the negative c. Okay, that's doable. We're going to go ahead and apply the natural log here. And I am going to change those two negatives right there, cancel those out, basically turning those to positive, so I can take the ln of positive 300. It's going to equal the ln and e will cancel out, so I'm left with negative c. So now we know that negative ln of 300 is our c. Okay, so that's another important piece of information. So now we've got c, we've got our formula. We can use the second thing with a t and an n, and we're going to try to find k. All right, so we're doing 500 here. 500 equals 550 minus e. We're looking for k. Our time now is 3, so negative 3k. And then we know c is negative 300. And remember, we're doing minus c, so if I minus a negative 300, that's going to turn that into plus the natural log of 300. All right, rearrange, pull that over. Negative 50 equals negative e to the negative 3k plus ln 300. Again, I'm going to change out those minuses. Boom, boom. And then we're going to apply the natural log to both sides. So ln 50 is going to equal negative 3k plus ln 300. All right, so you can do that calculator-wise, ln 50 minus ln 300, and then we're going to divide by -3. Now, we did talk in class about how our calculations might be a little bit different here, because if you keep the value in your calculator unrounded, okay, if you keep the value in your calculator unrounded and continue to use that throughout the problem, then you're going to end up with one final answer versus if we round to the 4 decimal places as we go, you'll end up with a different one. Now, on my math, I'm pretty sure I wrote the rounded value. So like for here, I have that K equals 0.5972. All right, but then I'm pretty sure that whenever I calculated it within the problem, I actually I used the entire value from the calculator and just rolled it over. Okay, so now we're going to go back in and we want to find the population when t equals 5. You can't see that, it's all up there, sorry. T equals 5, so I'm just going to plug in 5 for t now using our formula. So n is going to equal 550 minus e. Again, I'm going to write the 4-digit number here, but I'm pretty sure when I did my calculations that I did it with the entire number. So as long as we're grasping the concept here, that's what's most important. But your calculations might be a little different. Hold on one second, y'all. I'm about to turn that on. Yeah, keep the volume down until I'm done.
No, I'm doing mute volume.
Oh, okay.
So it's muted though?
Yeah, it's muted. Okay, sorry. Harper's awake. All right, example number 4. So again, these are the ones, like we were saying, that took so long for us to do because there was so much to calculate and to find throughout the problem. All right, so here we go. Example number 4. A new product is introduced through an advertising campaign to a population of 1.5 million potential customers. The rate at which the population hears about the product is assumed to be proportional to the number of people who are not yet aware of the product. By the end of 6 months, 375,000 people have heard of the product. How many have heard of it by the end of 1 year? Okay, so one thing I want to point out real quick in this problem, just to bring it to your attention, right here we are in millions, and here we are in 375,000. So you're going to have to make that adjustment somewhere in your problem. One will be a decimal or however you choose, but just make sure you can either write out all of them, but if you use any decimal abbreviations, like if we use 1.5, which is what I'm going to use, understand that's representing millions, so I would have to change 375,000 to the appropriate decimal. All right, so here we go. Let's start. We've got dy dt. It's going to equal our proportionality constant times our relationship. So our relationship is going to be 1.5 minus y. And remember, we're doing y being the number of people that have already heard. Okay, so again, we want that y to be across from that y, so I'm going to pull that down. And now we can cross multiply. And take the antiderivative. All right. So when we do that again, this is going to become a 0, so we've got to do the ln there. And again, we've got that negative because that derivative there would have been a -1 that was in the numerator. All right, y'all, and from here, everything's going to follow the same exact way. All right, so it's really just following the steps of example number 3. Oh, my bad. All right, we're following the steps of example number 3. All right, so I'm going to move that negative over, so the ln of 1.5 minus y, bless you, negative kt minus c. All right, and then we're going to apply the Eulers to both sides, giving me takes us there. So if we solve for y, I would just pull the y over basically, and then pull the e over. So y is going to equal 1.5 minus e to the negative kt minus c. All right, so there's our formula for y. Now, once we get to here, remember, we're going to find c, we're going to find k. All right, so if you want to go ahead and pause the video at this point and go back and look through or try it again, get out a plain piece of paper, since we've already done these, get out a plain piece of paper and just solve for c, given what you know. Okay, so if you want to do that, go ahead and do that. That way we can practice that, not just follow along with me and write it down. All right, so let's find C. We know right here that obviously after no time had passed, nobody had heard. So we're going to use the knowledge of, we have 0 at t equals 0. That's what we're going to use. Okay, so I'm going to plug in 0 for both x and y. So 0 is going to equal 1.5 minus e . Change my negatives, so I've just got 1.5 equals e to the negative c, and then apply the ln. So the ln of 1.5 equals negative c. Therefore, our c is going to be the negative ln of 1.5. All right, using what we know there. Continue on. And we're going to find k. And we're going to use that, so it's going to make that 0.375 at t equals 6. Remember that ln turns positive because it was minus c and our c was negative, so those two negatives are going to make a positive. All right, so again, we're going to work all this out. Okay, apply the ln to both sides. Actually, get rid of the negatives first. Okay, then apply the ln to both sides. All right, so again, my value here, again, it's the rounded value. I got 0.0479 for my k. And then I'm going to plug that in. Again, just to reiterate this, that's my rounded value here. But whenever I'm doing this into my calculation, I'm pretty sure I left the whole value in to be more exact. We want it after a year, so we're going to put 12 in as our time plus the ln of 1.5, and our value was 0.6557, or approximately 655,700 people. Okay? Just a reminder for the third time. Okay? If for some reason I don't have my calculator with me. Okay? So if for some reason this is off, understand that it is very likely that where I wrote this value, I used the entire value whenever I did this calculation for k. Okay, so just take that into consideration whenever you're going through these. All right, let's look at page 3. page 3. That other sheet back here. This back. All right, page 3. Sorry. All right, so let's see what we got. During a chemical reaction, substance A is converted into substance B at a rate that is proportional to the square of the amount of A. All right, proportional to the square of the amount of A. So that's going to give us the relationship. So dy dt is going to be the square of the amount. All right, obviously, again, we know we're going to use this, and we're going to use this. We'll use that in a little bit. All right, so dy dt equals ky squared. Okay, again, we need that y to go to the bottom. And we can cross multiply. So y to the negative 2 dy is going to equal k dt. Take the antiderivative at this point. Alright, so that's going to become a negative 1. So that'll be a negative y to the negative 1. It's going to equal kt plus c. And remember, we are solving for y. Okay, so that's going to give me negative 1. Callie, stop. Harper, get your sister.
Yeah.
Go see Bubba.
Yeah, girl.
Alright, negative 1 over y. Sorry, the dog crawled in my lap. Alright, kt plus c. So ultimately what's happening here is I'm putting this over a 1, and we're kind of just switching places here. So if I flip this, then I can flip this.
Yeah.
Alright, so y is going to equal negative 1 over kt plus c. Basically this turned upside down. I moved the negative over to here, and then that turned upside down as well. Alright, so let's find c. We know that's important. Okay, so we're going to use the first one we have. So 80 is going to equal negative 1 over k times 0 plus c. That makes this really simple. 0 plus c is just going to be c. So we have 80 equals negative 1 over c. And therefore these can just switch places, making it c equals negative 1 over 80. That was pretty simple. All right, especially after the last two. All right, let's find k. So we'll use the second piece. 25 equals negative 1, k times 1, minus 1 over 80, because now we know c is 1 over 80. All right, again, if we're using a decimal here, ultimately we're just trying to get k by itself. But if your answer is going to be a decimal here, you can kind of finagle this however you want, calculator-wise. Let's see what I did. We would have I made it into 1. All right, so 25 is going to equal, this is basically k minus, so I did negative 80 over 80k minus 1. Basically, I multiplied everything times the denominator, which would have been 80. So that gave me a negative 80 on top, an 80k, and then 80 over 80 would have been minus 1. And then that got rid of everything as far as my fractions went. Don't have multiple fractions. All right, so then we're going to multiply across. That's going to give me 2000k minus 25 is going to equal negative 80. And again, my abbreviated k value is negative 0.0275. They want us to find it for 3 hours. So just go back into our equation and plug that in. Negative 1 over, our k is negative 0.0275, or again, just use the value in your calculator, minus 1 over 80, and that's going to give me approximately 10.5263 grams. Okay. All right, last one of these.
Yes, sir. Sir? She's working.
All right. A population of 30 bobcats has been introduced into a national park. The Forest Service estimates that the maximum population the park can sustain is 250 bobcats. After 2 years, the population is estimated to be about 45 bobcats. According to the Gompertz growth model, how many bobcats will there be 5 years after their introduction? Okay, and then I give you a little note here. Okay, that the model assumes that the rate of change of y is proportional to the product of y and the natural log of L over y, where L is the population limit. Now, I am going to assign you a AP Classroom video here in a little bit on this, and you will see they actually put up some stuff about this model and these formulas at the very beginning. So just be mindful of that. I didn't tell you this in the problem, but it is an actual formula that you can use. All right, so here we go. Start off, dy dt is going to equal. All right, and let's see, it says the product of y and the natural log of L over y. So our proportionality constant, the product of y and the natural log of L over y, where L is the population limit. And it says the park can only, the maximum population up here is 250 bobcats, so it's going to be 250 over y. All right, we're not going to go through all of this again. And actually, when y'all were in class the other day, I showed you this. We just kind of dropped down and we said that the magic happens in here. Yay, the magic all happens. And we end up with the equation y equals 250 e negative c e to the negative kt. All right, so that's our formula. Again, we could have done all of this stuff for each one of these. Save on time. The magic just happens. So now we're going to find c. All right, so we know that it is 30 at t equals 0. So we're going to start with that. So 30 is going to equal 250 e negative c e to the negative k times 0. Goodness, that's a lot to write. Sorry. All right, so ultimately this 0, that's going to be turn into a, basically a 1 there. So if you divide by 250, we're going to get 0.12, and that's going to be e to the negative c. Take the natural log of both sides like we do often. Get rid of the e, so we're going to have ln of 0.12 is going to equal negative c. So ultimately c equals the negative ln of 0.12. So we found c. Now let's go find k. All right, plug it all in, divide here. Okay, take the natural log of both sides. And we're going to do all that math. So I'm going to divide ln of 0.18 by the ln of 0.12. It's going to give me 0.8087 e to the negative 2k. Again, we're going to have to apply the natural log of both sides to get rid of the e. So I end up with k equaling 0.1061. And if we want to figure that out for, what did they say, 5 years? So we're just going to plug in 5 right here into our t. So y is going to equal 250 e ln 0.12 e to the negative 0.1061 times 5. Plug all of that in and you get about 71.845, or we'll just say 72 bobcats. Again, y'all know my issue. I would want to drop that off to 71, but pretty sure AP wise, they will, as long as your math is there and your calculations are there, you should be good to go. All right. Okay, exponential growth is unlimited. However, when describing a population, there often exists some upper limit. We denote that by L, past which growth cannot occur. This upper limit, L, is called the carrying capacity. And is the maximum population that can be sustained or supported as time increases. A model that is often used to describe this type of growth is the logistic differential equation. All right, so that's right here. And again, on that AP video I'm going to assign, you're going to see stuff like this. L can be a couple of different places. This is where we have it here. And then, but ultimately they're basically saying there is an upper limit. I know that everybody thinks exponential growth is unlimited, but there does come a point where, like, especially if you're talking about like animals and things of that nature, if there's not but so much food, then they end up taking care of themselves. There does reach a certain point where you can't go any further. All right. So now we're going to get to the one that we did not cover in class. Okay. And there's a reason that all of this is open. Okay. All this right here is open because it does take a little bit of work to do this problem. All right. And we're going to throw back to when we did partial fraction decomposition in pre-calculus. All right, so let's see what we were given first. All right, so I'm going to move this all down. I want y and then 1 minus y over 150. All of that to the negative 1. So I move this whole part, all of this down, so that I could cross multiply. And antiderivative. Okay, so now, if I take the antiderivative here, all right, it's going to be antiderivative of each of these, so that's going to be y to the negative 1, basically, plus look, I made it that far. Oh no, I done messed up, y'all. You know what that means? Dun-dun. Okay, give me a second. Y'all know I can't handle it. All right, there we go. Better. All right, so now let's apply the antiderivative on the left. Okay, so that's going to become a 0, so we're going to have an ln of y here. All right, that's going to become a 0, so minus the ln of 150 minus y. All right, so to get rid of our, well, first of all, we're going to combine these. So remember, when we do subtraction on our log properties, that's division. So it's going to be the ln of the absolute value of y over 150 minus y. And now we're going to apply Euler to get rid of that natural log. All right. So there we are. Okay, so now I'll solve for y. Basically, this is going to jump over here, and we're going to have that y equals 150 minus y times e to the kt plus c. All right, so there's our formula for that. Now, obviously, we still have two y's here, right? So that presents an issue. All right, so I need to isolate and get only one y. All right, so if I do that, basically we're going to do this. Boom, boom. And I want to pull this one over. So I'm going to have this y over here already. That's going to be plus y times e to the kt plus c is going to equal the 150 e to the kt plus c. Now I can factor out my y. And now I can get y all by itself by dividing. So y is going to equal the 150 e to the kt plus c over 1 plus e to the kt plus c. Now, that is one way that you could have done it. I'm going to show you another way. Let me do something else up here. And then I'm going to come back to this point right here. Okay, I'm going to come back here and I'm going to kind of show you something else you could have done over here. All right, but at this point, we don't know. We're going to have to use partial fractions. Okay, so if we remember partial fractions. All right, it's going to be 1 over y and then 1 minus y over 150. And that's going to equal a over the first plus b over the second. Now, when y'all did this, you would have had like two regular factors like x plus 3 and x minus 4, something like that. And you would have a over x plus 3 and b over x minus 4. And it'd just be a little bit simpler. But ultimately, you're trying to eliminate one of these by making this go away. All right, so in this situation, like if we were to multiply everything here by our common denominator, which is this whole thing. The left side's just going to be 1. The a side is missing the 1 minus y over 150. And the b is just missing the y. So now what you do is you pick numbers to go in for y. To cancel out a and to cancel out b. So like for a, ultimately I want this right here to be 1 because 1 minus 1 is 0 and a times 0 is 0, and then I would just be left with b. So what would make this 1? I want y to be 150. So I'm going to let y equal 150. So if that's the case, then 1 would equal, so 150 over 150 is 1. 1 minus 1 is 0. A goes away, so it would be 150b. So then 1 over 150 is b. Okay, I'm going to go right next to it, and I'm going to let y equal 0. Okay, because if y equals 0 here, that goes away, right? 0, that goes away. 0 divided by 150 is 0. 1 minus 0 is 1. A times 1 is a, so 1 equals a. So now I can plug those back up here, and I get my partial fraction, which would be 1 over y, because a was 1, plus 1 over 150 over 1 minus y over 150. So if I multiply everything in this fraction by 150, right? So 150 over 150 would give me a 1. So plus, sorry. So 150 over 150 would give me a 1. And then 1 times 150 would give me a 150 minus 150y, so it'd be 150 minus y. So now there is my partial fractions. Okay, so let me draw a line here. I want to come from here and show you something right here. All right, we had this. Okay, I could have flipped both of these, basically making this 150 minus y over y equals e to the negative kt minus c. So ultimately, all I did was I flipped this left side, okay, and then I flipped the right side, which made these negative. Okay, I didn't physically flip it, I just made the exponents negative to keep it the way it was. And then you could have pulled your y over. Okay, and then you could have, so I multiply my y up, and then you could have pulled this y over. So 150 would equal y e to the negative kt minus c plus y. And then you could have factored your y out there. So 150 would equal y e to the negative kt minus c plus 1. And then divided. So this and this are the same. Okay, and then from here, I am going to eliminate this by basically sliding that apart. So see, this and this, so it could have been either one. So like you could have manipulated this to turn into this, either way. So much going on my arrows and which way we needed to go. One of the more difficult, that's why I did not put one of those on your assignment for your asynchronous day. All right, so the last thing we have down here is given the select field of the logistic differential equation y prime equals 0.8 y1 minus y over 5. Graph the solution curves for the initial conditions y equals 0, y of 0 equals 1, y of 0 equals 5, and y of 0 equals 8. So all I'm going to do here is I'm going to go into my graph. Okay, y of 0 equals 1 means that the ordered pair 0, 1. So 0, 1 is right here. Okay, and like this looks like a pretty defining line for me. So ultimately what I'm trying to do is follow along. 0, 5 is right here. Well, through that point, looks like we're just going straight through. And then 0, 8 is here. And again, it looks like we're just kind of coming down. Now, mind you, this is individual through each one of the points. It's all on the same graph, which is this, but individually through that point, what is it like the graph is doing? So just be mindful of that. It's not. And then, yes, I have a bunch of arrows drawn right here because I felt like this was us whenever we started this lesson. We were like, Meltdown Central. So hopefully this makes it a little bit easier, a little bit better for you. Go back and review everything that happened, and I will see you all in class tomorrow. Don't forget to do your assignment for today.